atomic masses and where they come from, and then we're looking at moles and all mole calculations. We're basically doing 4 Chem 1 days in 1 day. So those of you who feel like you've been away from Chem for a while, this is going to be your time to start reviewing on your own some quick stuff. So looking at this, we are asked to find the average atomic mass. Average atomic mass, sometimes known as molar mass, is basically what's on the periodic table, that decimal number there. It's an average of all the different isotopes of a substance. The units on this could either be these little μ's, which stand for atomic mass units. You may also see it written as molar mass. The units on this could also be grams per mole. What does grams per mole mean? It means that if you have 1 mole of any of these substances on the periodic table, it's going to weigh however many grams is under it. For instance, if I have 1 mole of chlorine, it's going to weigh 35.453 grams. What do I mean? How do I weigh a mole? What is a mole? What? What is a mole? 6.02 times 10 to the 23 things is a mole. Okay? A lot of hesitation out there, and I don't know why, because if I were to ask you what a dozen is, you'd know immediately. This is the exact same thing as a dozen, except it's a very large number. Why do we use such a big number? Because they're small. Okay? We're trying to make the numbers more workable while using the unit of mole. Okay? So if I have 6.02 times 10 to the 23rd carbon atoms, theoretically that should weigh 12.0107 if I were to put that many on a balance. Okay? So not only is atomic mass units, which is a unit derived by carbon, 1/12 of a carbon atom is an atomic mass unit, it also is grams per mole. So these are really easy problems. You've done them before. To find the average atomic mass, you basically need to find the weighted average of the mass of each isotope. So let's take a look. We've got the percents, and we've got the actual masses of each of those isotopes. I'm going to set it up by multiplying what? The percent in decimal form times the mass, and then add them all up. Right? Just like you'd figure out your grade as a weighted grade. So I'm going to look at first neon 20, and it weighs 19.992 AMUs times, I don't put 90.92, I got to do it in decimal form, so it's 0.9092. Now you can either go long ways on the paper and add to the right, or I'm going up and down because I have more room this way, plus 20.994 AMUs. Be careful with these small percents. It's 0.0257. So many people will mistakenly write 0.2. And then I'm going to add 21.991 times 0.08. I do have a question before we add these up, and you guys can add them up in the meantime while I'm talking. This is an isotope of neon that's got 20 things in the nucleus. So if each proton and neutron weigh 1 AMU, why doesn't it actually weigh 20? Shouldn't it? Shouldn't it be a whole number? We talked about this. No, electrons weigh more. If anything, it should be more than 20. No, these are actual. We say the periodic table has decimal places because it's an average of all the isotopes, but this is an actual single isotope with 20 things in the nucleus. Why isn't it weighing exactly 20? What? Space. Let me ask you. This is all in the nucleus. We're talking about the weight of the nucleus because we discount the weight of the electrons. What's in the nucleus? Protons and neutrons. Tell me about protons. They're positive. So you've got all these positive things shoved into one space. Does anyone see a problem with that? Don't they want to repel? But they're not. Why are they staying together? There's something called binding energy. Does that ring a bell? Okay. Binding energy is the energy that holds that nucleus together. Energy's got to come from somewhere. So some of the mass from that 20 AMUs is converted to energy using E equals mc squared, and that energy holds the nucleus together. And that missing mass here is called the mass defect. We are going to calculate this eventually, not today, but I just want you to be aware of it, okay? All right, what did y'all get for the average atomic mass here then? 20.656? 65. We're going to stick with whatever's here that's been in all these, so 658 or 656? 656. And the units on this, you could put little atomic mass units or you could do grams per mole. I use them interchangeably all the time, so just get used to hearing it. Okay, good. Let's try the next one. Another problem very similar. 2 isotopes of chlorine exist in nature. What is the mass of the other isotope of chlorine? Okay, so we know there's 2. We know one of them, chlorine 35, is 75.77%, and it has a mass of 34.96885. We're trying to figure out what this other one is. So we don't know its mass, but what do we know about it? It's percent. How did you figure that out? Subtract 75% from 100, and we get 24.23. Look at Denise do mental math, Demo. I can't do mental math, so that was a huge deal for me right there. I felt very proud of myself for that. Anyway, I'm just kidding. So now that I know the percent, I can figure this out, but I need something else. What am I going to set it all equal to, Grant? Yeah, the average atomic mass on the table is 35.453. So I take that from the periodic table, 35.453, and I set it equal to 0.7577 times 34.96885 plus 0.2423, whoops, 23, what do I multiply that by? X. This is where I need y'all to hopefully be fast so people at home don't have to wait since I can't pause anymore like I used to. All isotopes, the question is, why do I know that the percents are equal to 100? In nature, everything adds up to 100. They told us there's only 2 isotopes. Okay, so if one of them was 75, the other has to be 100 minus that. If there's 3 isotopes, I wouldn't have been able to do this because I wouldn't know. I'd need more information. Okay, what'd y'all get? 36.9. Give me... We're still missing one, but that's okay. Grams per mole. So that's the mass. So if I wanted to put a little symbol here, what would it be? Chlorine, if I wanted my condensed formula, 37, right? It'd be chlorine 37. Questions? There's going to be some different types. The thing about class is different types of problems can't be done. I can't do every permutation and combination of problems here, so you're going to run into a problem where you actually have to find the percents given all the other information. So if I know my average atomic mass here, and I know a percent, I don't know a percent, and I know the other average atomic mass, and I need the percent, and I know this average mass, if I have to solve for those percents, but I know this, this, and this, how do I solve for those percents? Does anybody remember? Okay, 100 minus x for one and x for the other. That's right. But instead of 100, that's a percent. How do you make 100% a decimal? You make it 1. Caroline, what was your question? You figured it out? Okay. All right, so this is the type of problem you'll have on your homework. There'll be a couple like this. So be sure to do your homework to practice all the different possibilities of solving these problems. Okay, y'all ready to move on to moles? All right. I inserted a blank page here. You don't have to draw this down. This is more of a little kind of thing to help you remember. You all have seen this, except you haven't seen my version. This is what I call Demo Nation. In Demo Nation, in my chem world, in the center is Moletown. Moletown is a nice little suburb. People hang out. It's pretty quiet, good place to be. And it's surrounded by 3 different places, one of which is called Gramland. Gramland, lots of rolling hills. Okay, so if I wanted to get from Mole Town to Gramland, moles to grams, who remembers how I get there? If I have a certain number of grams of a substance, how do I get to moles? Back and forth. The molar mass. We're going to call it the GFM bus. Gram formula mass bus. So what we do is we add up on the periodic table the grams per mole, and we know that for every 1 mole of something, we have a certain amount of grams. So that's how we get back and forth between grams and moles. When you feel like living it up, you go to the big old particle city out here. Woo! Those are sets of skyscrapers. And this is Particle City. In Particle City, we're actually referring to atoms, molecules. I'm going to introduce the concept of formula units if you haven't learned them yet. Formula units are actually the smallest unit in an ionic compound. Okay? When we talk sodium chloride, for instance, sodium chloride and NaCl, those aren't molecules. Have y'all ever seen table salt? Obviously you have. What does it look like? Huh? They're crystals, right? In each one of those crystals, you've got a complex building of multiple units of NaCl. NaCl attached to NaCl, attracted to NaCl, attracted to NaCl. Okay? Those aren't molecules. Molecules are named molecularly with the prefixes mono, di, tri, and so on. So rather than saying molecules of NaCl, I'm going to say formula units. Any ionic compound, you'll start to hear me say that. So if I want to get from moles to particles, be it atoms, molecules, formula units, what would I need? Louder. 6.02 times 10 to the 23rd. If you look at the backboard, there's the number. It's huge. And that is 6.02. That is called Avogadro's number. Avogadro was the man in charge of the mole. And we call it the Avogadro Express is how we get there. Avogadro. We're going to jump on the Avogadro Express, and we use that conversion factor. Now the last place is a place we're not going to visit this unit, but it's Volumeville. In Volumeville, there's many different ways to get from moles to volume, but if we're at STP, who remembers how to get there? Nice. This is only good for gases. And another high five out there. 22.4 liter tractor. That's a really, see, look how I spell. I know that is so wrong, but I don't know how to fix that. How do you spell tractor? There's no K, seriously? But you race around a track. All right, tractor. Is it OR? You sure? Okay. All right, we're not going to go there, though, to Volumeville just yet. There's also other ways to get there. Remember PervNert, PV equals nRT? That's from moles to volume as well, using that formula. Lots of different ways to do that, but we're just focusing right now on Gramland, Mole Town, and Particle City. So this is going to be super hard to read, I know, and I apologize now, but we're going to do our best to get through this. So let's see what happens when I go up and down. Okay, I can still go up and down. All right, learning curve on the Macintosh for me. How many moles are in 18.0 grams of sugar, C6H12O6? So we're going to start with our given, 18.0 grams. I need y'all to be on the ball with Calcs again today, C6H12O6. We're going to keep our sig figs based on the given. When we're determining molar masses as a class, let's just decide to go to 2 decimal places. The only reason I'm choosing that is the periodic table on the AP exam has everything out to 2 decimal places. And on the AP, I always want you to carry it out to max decimal places. So let's round to 2. How do I do the conversion, though? I'm in Gramland. I got to go to Mole Town, so I do molar mass. Do y'all remember how to find molar mass? Add up all the masses of the individuals. It's about 180. What is it? So for every 1 mole on top, it's 180.18 grams. The conversion that you're always going to put in is always per 1 mole, per 1 mole, per 1 mole, whether it be particles, whether it be formula units, whether it be molar mass. It's always per 1 mole. So to 3 sig figs, what is my answer? Anybody? 0.0 what? I need 3 Sig Figs. 999 moles of C6H12O6. Did I tell this class about that car, the cube story? So the other day, I thought it was so cute. There was a white, you know the cube, they're square. There was a white cube driving down the street, or was it on Facebook? I can't remember where I saw it. I think it was on Facebook. Someone took a picture of a cube driving, a friend of mine, and the license plate was C6H12O6, and it was white. So what is it? It's a sugar cube. Isn't that cute? I wish I would have thought of that. I thought that was adorable. I wonder if they meant that. Of course they meant that. What is the weight of 4.50 moles of barium sulfide? Here's where nomenclature is important. If you don't know barium sulfide, you're going to get the wrong molar mass and get the wrong number of grams. We're looking for weight. So we're going to start with 4.50 moles of barium sulfide. All right, now what do we do? 1 mole is how many grams? 4.4 what? 0.40? 40 grams. All right, so that gives me to 3 Sig Figs. $740 with a decimal grams. Thank you. All right, let's jump down to number 4. How many moles are in, is that 3.9? I'm having a hard time reading it. Times 10 to the 28th. Molecules of methane. So we're starting out this time with molecules. We're in particle city, and we want to get to molecules. I'm sorry, we want to get to moles. So we start with molecules. How do I convert? For every 1 mole on top, I have 6.02 times 10 to the 23rd molecules. I abbreviate molecules with a LEC, just so the difference between moles and molecules is obvious. So to 3 Sig Figs, how many moles do we have? So 64,800? 64,800. That's a lot of moles. Okay? What if I were to add to this problem and say, oh, no, I'll change it for the next one, for number 6. Let's look at number 6. Number 6 is a little bit tricky in that it asks for how many atoms of oxygen. Oxygen's a diatomic and is usually in molecule form, right? So when we multiply by 6.02 to get molecules, for the first time, we end up getting molecules. How do I go from molecules to atoms? 1 molecule, 2 atoms. And so we'll take that additional step. So we're going to start with our given of 2.50 moles of O2. How do I get to, I'm in mole town, I got to get to particle city. So for every 1 mole, I have, what is my first unit going to be right here? Atoms? No, it's going to be molecules. Whatever unit your given is in is the unit you get when you multiply through by 6.03 the first time. So this is molecules. But I don't want molecules, I want atoms. So for every 1 molecule I have 2 atoms. Is everybody with me there? Yes, Jessica. For this one, there's only a diatomic. So we'd say 2 atoms. But if it were to be a compound like methane, CH4, and I asked you for atoms, you'd multiply by 5 because there's 1 C. They might even say, if it's CH4, they might ask you how many atoms of just H. So then you'd multiply by 4. So you just play with it that way. All right, to 3 sig figs, we're going for atoms, so we should get a pretty big number here. And I'm going to write it up here because I'm out of room. What? Okay, good. Y'all ready for the 2-step problems? Not much harder, but now we're going to always go through mole town. I didn't mention that earlier, but on the mole map, can I get to from Gramland to Particle City without going through mole town? We always got to go through mole town. So let's go ahead and do some of these problems. Okay, how many atoms of aluminum are in 2 moles of aluminum fluoride? We're going to start with our 2 moles. What's the deal, folks? Wait, this is still single steppers. I want to move to 2 steppers. This was not on my last presentation because I couldn't see it. No, that's right. It is. Okay. So we got to go from, what happened? I scrolled down. Okay, got it. How many molecules are in 198.5 grams of sodium chloride? So I'm going to start with this, 198.5 grams. I'm going to change this problem because it's kind of wrong. It's formula units. We do not have molecules of NaCl. I know it's semantics, but it's wrong. All right, I want to get to formula units, which is in particle city. So I got to go through moles. Right on, Kiss. I got it now. I'm going to remember. All right, so what do I do? For every 1 mole, louder, 58.44 grams. All right, now my grams cancel. I'm in mole town. I want to get to particle city. For every 1 mole I have, particle city. Thank you. And this is, I'm going to do FU for short, formula units. All right. So how many formula units of sodium chloride do I have? It's 2.045 times 10 to the what? 24 formula units of NaCl. Why did I do 4 sig figs? Because there's 4 sig figs in my given. Okay. Let's see. I want to do a tricky one. Ooh, let's do this one, the one that I saw earlier. How many atoms of aluminum are in 2 moles of aluminum fluoride? So we're starting with 2 moles. This is kind of a different 2-step problem. Aluminum fluoride is what formula? Nope. AlF3. This is where it's crucial you get the name right. So I'm in mole town. I want to get to atoms, which is in particle city, but first I want to get to not molecules, I want to get to formula units. So how do I get to formula units? For every 1 mole, 6.02 times 10 to the 23rd formula units. I'm mixing up my crosses and my railroad tracks. It doesn't matter. And then I need to get to aluminum atoms. How many aluminum atoms are in every 1 formula unit? 1. For every 1 formula unit, I have 1 Al atom. If they were asking me, though, for fluoride, I would have multiplied it by 3. Okay? So, to 3 sig figs. To the 24th. Thank you. Atoms of aluminum. All right, I'll let you guys pick another one out of the remaining. Number 10, how many moles of carbon? All right, that's a good one. We're going to start with molecules of propane. So 1.00 times, I can't read that exponent, what is that? Times 10 to the 20 molecules of propane. C3, I can't read it, but I know what the formula is because I know organic, times, all right, I want to get to mole town. I'm in particle city. So for every, I want to get to moles, I'm in particle city. 6.02 times 10 to the 23rd molecules. Okay, I'm in moles. This is moles of C3H8. Here's something that students miss, and I want to make sure you understand. If I have a mole of cars, all right, how many moles of steering wheels do I have? 1 mole. If I have a mole of cars, how many moles of tires do I have? 4, not including the spare, 4. If I have a mole of C3H8, how many C's do I have? 3 moles. So for every 1 mole of C3H8, I have 1 mole of C. So it's important to realize anytime you have a formula, are we doing carbon? Oh, 3. Did I say it and write the wrong thing? I said 1? It's 3. It's 3. I meant 3. So what's important to realize that when you see a formula, it's not only a ratio of number of atoms, it's also the ratio of number of moles because every mole has the same number of atoms in it. Okay? So now that I have that, what is the answer to 3 sig figs? Times 10 to the negative 4? 0.998? No, it can't be. What? 4.98. And this is moles of C. So when you're looking at answers, make sure your answers make sense. For instance, if you see a number like 5 times 10 to the 60th, that's probably an answer in particles or something that's really small. You're not going to have an answer in moles that's to a really big exponent. Okay, so just think, does my answer make sense? So looking at the next slide, which is our last slide, do you see this format? You know what that means? Yeah. So when I give you something in this format, possibly, I don't need to see work, okay? There'll be space for you to do work to fill in this table, but I don't need to see the work. But if you look, you can kind of think of the conversion between each. How do I get from molar mass to mass? I'm going to either multiply or divide by the molar mass. Okay, how do I get from grams? Sorry, my bad. This is the molar mass. How do I get from grams to moles? I'm going to use the molar mass to get back and forth. How do I get from moles to number of atoms or formula units? I'm going to use Avogadro's number there. Okay, so once I know the molar mass, I can do all that, or I can use that stuff to find the molar mass. It depends what information I'm given. So looking at the first two, I've got the molar mass and I've got the mass. How do I get to moles? 0.825 grams. To get to moles, I know that for every 1 mole I have 98. So I heard someone already say, I divide it. Sure. That's awesome that you can do that in your head. But you might screw it up if you don't kind of jot down. I still kind of had to jot stuff down. I have a hard time seeing that kind of thing in my head. So I want to make sure I end up with moles. So what do y'all get here for 3 sig figs? What now? 418? Oh. I'm getting deaf as I get older. I think I also have a hard time with guys' voices. Some of the frequency. It would be smaller. Yeah, what is it? Great. So anyway, I have a hard time hearing some male voices at certain frequencies, especially those of you that talk like that. All right, how do I get then? This one you probably don't have to write down. How do I get to number of in this case, formula units? Multiply by 6.02, and what do we get? Times 10 to the what? Okay. All right, this next one, all I know is number of formula units for this chromium 3 oxide. What else can I figure out? What can I do? I heard two things, and I can do two things. First, I could find the molar mass. So some of you go ahead and do that. And then I heard, we're going to save some time, I heard someone say divide. What are you dividing by? Correct. If you divide by Avogadro's number, you can figure out the actual number of moles. So this half of the room do Avogadro's number division. This half do molar mass, since you guys are closest to the periodic table. Holler out something when you get it. 1.60 moles. Molar mass, people? 151.99? 99. Awesome. So how am I going to find grams? I have moles, right? 1.60 moles. And I know that for every 1 mole, I have 151.99. So I'm going to multiply by that molar mass. And to 3 sig figs, I get 243 grams. Okay. Uh-oh. I don't know what this is. I know grams and I know moles. That's it. What's one thing I could do? Find the number of atoms, or molecules. We don't know what it is. It could be molecules, whatever. So we're going to go ahead and do that by doing what, Michael? Perfect. If we multiply 0.476 by 6.02, we get times 10 to the 23rd. Great. What about the molar mass? Exactly. That's why I'm so big about you knowing the units of grams per mole. You have grams, you have moles. Grams divided by moles. What do you get? We'll leave it at 3, 119. Awesome. Oh, and I did tell you 2 decimals for molar masses. All right, what is it? 3.3? Okay. Ah, our friend molybdenum. We really can't do anything until we get its molar mass, because we can find atoms. How do we find atoms? Multiplying 60. Is that 62.8? 62.8. What do we get? 25 or 24? 25. All right, molybdenum. I see it. I see it. I see it. I see it. It is 95.94 AMUs, or grams per mole. So what do I do now? I know 62.8 moles. How do I find grams? Multiply by the molar mass, and I get 6,030, 6030. And there it is. Y'all were rock stars today with the calculator. Thank you so much. That made it go much quicker than first period. I'm going to go ahead and stop the recording. You can start working on your homework, or while I'm uploading this on the computer, you can come to me and ask me any questions from yesterday's homework. Look at the keys, though, now before you do that, because now the keys should be nice and pretty and legible, okay?